my name is Victoria. I'm a social media contributor at Core, and welcome to our YouTube channel. Today we're going to continue with our educational series called the Core Academy, and we'll talk about what is blockchain. We'll take an in-depth look at blockchain technology. You have probably heard a lot about blockchain before, but you may not be clear about what a blockchain actually is and how it works. So let's dive in. What is blockchain? As its name implies, a blockchain is a chain of blocks, where the blocks contain sets of transactions and the chain is a link made up of cryptographic hashes. In Bitcoin, for example, all transactions go into blocks which are mined, and the header for each block contains a reference to the previous block's header. Blockchains are often described as distributed ledgers. Ledgers are just a bookkeeping system for tracking transactions, which occur in blockchain blocks. And because every full node in a network like Bitcoin has a complete ledger, we can say that it's distributed. So how does blockchain work? There are a few critical properties of blockchain that are worth discussing in detail. Decentralization is the first one. In the context of blockchain, decentralization means that there is no single entity controlling the data or controlling access to the network. Each participant, a node in the network, holds a copy of the entire blockchain ledger, and every change in the network is added and verified through a consensus mechanism. The decentralized structure enhances security, transparency, and trust because there are no single points of control. Consensus mechanism. A consensus mechanism is the means by which nodes in a blockchain network agree on the state of the ledger. It's how computers in the network cooperate to keep their record accurate and secure. Proof of work and proof of stake are examples of common consensus mechanisms for different blockchains. But what is proof of work? Proof of work is a method of verifying transactions on a blockchain in which an algorithm provides a mathematical problem that computers race to solve. Each participating computer, referred to as a miner, solves a mathematical puzzle that helps verify a group of transactions, referred to as a block, then adds them to the blockchain ledger. The first computer to do so successfully is rewarded with a small amount of cryptocurrency for its effort. Proof of stake, the number of transactions each person can verify, is limited by the amount of cryptocurrency they are willing to stake or temporarily lock up in a communal safe. Each person who stakes crypto is eligible to verify transactions, but the odds you will be chosen typically increase with the amount of crypto staked. Now we'll talk about the role of consensus in crypto. Both proof of stake and proof of work rely on consensus mechanism to verify transaction. This means that each verified transaction must be checked and approved by the majority of ledger holders. Blockchain immutability means that once the data has been recorded in a block and added to the chain, it can no longer be changed or removed. This creates an unchangeable, immutable history of transactions. What are the real-world applications of blockchain? The potential use cases for blockchain are very broad and could have an enormous impact on finance, coordination, ownership, and other aspects of day-to-day lives. One of the real-world applications can be cryptocurrency. Cryptocurrency is a digital, encrypted, and decentralized medium of exchange. You can use crypto to buy regular goods and services, though most people invest in cryptocurrencies as they would in other assets like stock, gold, or silver. While cryptocurrencies is an exciting asset class, it is more volatile than traditional assets, so purchasing it can be quite risky. Bitcoin, Ethereum, and Core are all examples of cryptocurrencies. Next real-world application of blockchain is a supply chain. Blockchain technology can be leveraged to provide real-time tracking and end-to-end visibility of products throughout the supply chain, from initial production to final distribution. This could increase efficiency between the different parties. The last real-world application of blockchain I'm gonna mention today is voting systems and governance. Blockchain can be leveraged by voting system to provide a secure and transparent platform for recording and verifying votes, decreasing the risk of fraud or manipulation. So what are the advantages and challenges of blockchain? The advantages of blockchain include security, transparency, and elimination of intermediaries. A big part of what miners do is secure blockchain network from attacks. Distributed public ledgers like Bitcoin make it easy to see which wallets control which assets, though individuals' identities remain anonymous. Blockchains eliminate the need for gatekeeping intermediaries that control who can access to the network. Crypto transactions are peer-to-peer, with no need for a bank or other centralized intermediaries. So what are the challenges? Scalability issues. There's no doubt that many consensus mechanisms like proof of work in Bitcoin are slow. From the beginning, there has been concern about whether such technologies can act as a monetary rail supporting billions of transactions, but there has been a tremendous amount of research and progress invested in resolving this issue. Energy consumption in some blockchains. Many blockchains are secured through computationally intensive processes, and that requires energy. As blockchains grow in importance, that would mean they would consume a progressively larger amount of energy, which is something that has drawn criticism. Regulatory concerns. Many have expressed fears over the possibility of different governments simply banning the use of blockchains and cryptocurrencies. In conclusion, blockchain technology is revolutionizing how we record and validate transactions in the digital world. The potential for its applications are expanding far beyond cryptocurrencies, impacting industries as diverse as healthcare, gaming, chain management, and more. Thanks for watching, and to continue learning, stay tuned for our next to our YouTube channel. Now that we've covered what Web3 and blockchain technologies are, let's spend some time going over the different types of blockchains. There are three primary types: public, private, and hybrid consortium. This lesson will break down each type and look at the different benefits and applications for each. Public blockchains are open, decentralized networks that anyone can join and participate in. The three key distinguishing features of public blockchains are that they are permissionless, transparent, and secure. Public blockchains are permissionless, meaning anyone can build and participate simply by joining the network without having to register with anyone to gain access. Transactions on public blockchains are public, meaning that they are viewable and verifiable by anyone. This transparency is a key factor in building trust in blockchain. Public blockchains are typically secured through robust consensus mechanisms such as proof of work or delegated proof of stake, making them resistant to censorship and tampering. When people talk about blockchains, they're usually referring to public blockchains like Bitcoin and Ethereum. Private blockchains are permissioned, distributed ledgers controlled by a single entity or organization. The three key features of private blockchains are that they are permissioned, private, and centralized. With a private blockchain, access and participation are controlled. Users are often known and verified entities. Transactions on private blockchains are not visible to the public, making them more suited to enterprise applications. Compared to their public counterparts, private blockchains are centralized and they are often operated by a single entity, such as a corporation. Both hybrid and consortium blockchains blend elements of both public and private blockchain. The four key distinguishing features of hybrid consortium blockchains are that they are customizable, semi-permissioned, collaborative, and highly scalable. Hybrid blockchains are highly customizable, allowing organizations to build the network for specific needs or use cases. Only a predefined group of known participants can operate and secure the network. Consortium blockchains are often used for collaborative efforts among organizations or industries where trust and verification among consortium members is paramount. Consortium chains can offer scalability benefits over fully public networks while still maintaining some level of decentralization. Hyperledger Fabric is a blockchain framework that allows interested parties to create distributed ledger projects for internal use. Here you can see a Venn diagram to help you make sense of the similarities and differences between public, private, consortium, and hybrid blockchain. In conclusion, whether you're talking about public, private, or hybrid consortium blockchains, each approach has distinct advantages and disadvantages that help drive its ideal use case. To continue learning, stay tuned for next video and don't